So this differential S parameter matrix, the first analysis that you must start is the upper left, which is differential in, differential out. Why? This is how the device performs in the real world. So you want to take a look at insertion loss, return loss, forward and reverse, and look at that, number one. In the lower right, common in, common out is not quite as important, and you're hoping there's no mode conversion, so you have to look at common signal. But the real interesting things are really the mixed mode S parameters. And we talked about EMI susceptibility and EMI emissions and how it relates to crosstalk. And so I want to try and give you like an intuitive understanding of how you can think about mode conversion so you can help identify not only the amplitude of crosstalk, but spatially the location of it, where it's happening in your channel.
The fundamental S parameters that we use, we can look at the single-ended S parameters, and then we can transpose those into differential S parameters, and I'll talk a little bit about that on the next slide. The point I want to make on this slide is this. If you have two single-ended lines, let's say they're far enough apart that there's no coupling there, then on the left-hand side, you have the frequency domain matrix of these 4 ports, and on the right-hand side, we have the time domain parameters. Now, if you're like me and you're a TDR scope lover, and you love to look at impedance profile, then you're going to look at T11 through T44, which is the impedance profile of all of these right here. Well, simply, you can look at the FFT transformation, and there's a unique mapping into return loss. So TDR is the same thing as a return loss, but just looking at it as a function of frequency instead of time. Likewise, the insertion loss in the frequency domain is analogous to time domain transmission. Again, a one-to-one mapping using FFT or IFFT. And then these terms in green are the near-end crosstalk, which you can look at crosstalk in either domain, and it's helpful in both domains. I would probably argue it's more intuitive in the time domain, okay? And then likewise, far-end crosstalk. So all of these things that you've learned as a digital engineer can be applied into the frequency domain quite readily.